As we continue to travel with Harold and Maude, our next step of the journey is the hospital. You'll recall that Harold was conked on the head by a ladder. This was a rather unfortunate incident. He is now in the hospital. It's a rather interesting hospital. They don't have any beds. They just fly high enough that there's no gravity and the patients just sort of float in the air, as I've illustrated here. And when you're in a hospital, you often have an IV in your arm. And usually there's just a bag of liquid that's then flowing into your arm. Well, they ran out of IV bags. Fortunately, they had this lovely cylindrical container with a radius of 2 centimeters. This is full of the medication that's flowing into Harold's arm. And it's flowing in at a rate of 0.003 cubic centimeters per second. Now, I am not a medical person. I just picked a number. So, if any of you are going into medical fields, I do not mean to imply that that is a reasonable rate at which to have things flow into a person. After all, this is the floating hospital that uses cylindrical containers instead of IV bags. I think you get the picture. Okay, so what we want to know then is how fast is the level of medicine in the nifty cylindrical container dropping? Because if it starts out full, as the medication flows into Harold's arm, the level's going to be dropping. So basically, at each moment in time, we're going to have a little miniature cylinder of medicine inside of this larger cylindrical container, the top of which will be empty because some of the medication has flowed into our dear beloved Harold. Okay, so let's see. I think I'm just going to label that as H for the height of the medication. And that's what I want to figure out how it's changing. And so I have to say, well, what else is changing that I know? I'm noticing this is given to me as a rate of change. So this is describing something that's changing. And this thing that's changing is measured in cubic centimeters. So I think that's volume. So it looks like we're looking for a relationship between the volume of the medication in this container and the height of that medication in that container. And since it's always going to be a cylinder in shape, the volume is equal to pi times the radius squared, so that would just be 4 pi in this case, times the height. Okay. So the volume of a cylinder, let's just write this down, is pi times the radius squared times the height. As we work through this section, a number of geometric shapes will come up. I do expect that if a geometric shape comes up in class, these lecture videos, or in the homework, that you're familiar with the formulas for those. But I won't stick in a geometric formula for a three-dimensional shape if you haven't previously seen it, assuming you're being a responsible student and watching the video lectures and doing the homework. The one exception to that is a sphere. I believe a sphere shows up in one of the homework problems, and just one. So that you won't see a whole lot more of until you get all the way to third semester calculus. So if I give you a problem with a sphere on a quiz or an exam, I would give you the formula. But now, if there's a cylinder, I'm expecting you to know the formula for the volume. And it's pretty straightforward. It's just one of these things where it's the area of the base times the height. The area of the base just happens to be a circle. Okay, so here we've got it. That's a function of time. That's a function of time. Let's take the derivative with respect to time. So the derivative of v is going to equal the derivative of 4 pi h. Now here I really don't have function compositions. That's just v. I'm not plugging that into anything. So its derivative is just v prime. And that's going to equal 4 pi as a constant. We had that many copies of h. We're going to get that many copies of h prime. Nice. I like this example. Okay. So we want to solve for h prime, so we need to plug in v prime. Now, I know the absolute value of that is 0.003. Okay. Is the volume of medication in this cylinder increasing or decreasing? It would be decreasing because some of the medication is flowing into Harold. Okay, so V prime is negative 0.003, and that's going to equal 4 pi times H prime. So let's just divide by 4 pi. Now, I do not want to mix fractions and decimals. That we can simplify. So I've got H prime is negative 0.003 over 4 pi. I think the easiest thing is to just get rid of the decimal, and I'll do that by just multiplying by 1 in the form of 1,000 over 1,000. 3 zeros, that's going to move my decimal 3 places, so the top becomes negative 3, and then over 4,000 pi. Okay, so that's my derivative. Let's now answer the question in words and give the appropriate units. So we were asked how fast the level of medication was dropping. So the level is dropping. That word right there accounts for the negative sign. And so it will be at a rate of 3 over 4,000 pi. And then I need the units. Okay. So what were the units for the height? Because that's what we're saying is changing now. Those would have been centimeters. I often see people say centimeters cubed because those were the units for our other rate of change. But the height is one-dimensional. Volume would be cubic centimeters when the dimensions are measured in just plain old centimeters. Okay, this was 2 centimeters, not 2 cubic centimeters. Okay, so it's just centimeters and then per second because those were the units of time that we used for the other part of the problem. All right, we shall hope Harold recovers.